Well, all right. Welcome back, and let's definitely get started. First off, I just wanted to say, congratulations, right? This is the first major milestone of this semester, and I know a lot of people are feeling a lot of stress right now, and I can see it, I can feel it, I get your messages, I know it. Um, but I think you all should also take a moment and just be proud of what you've been able to accomplish so far this semester. This class, at least, is really organized into three separate phases, and we really have passed that first phase. And I'm not going to say the second phase is necessarily easier than the first phase, but I think it's a lot more aligned in terms of what we're doing in class together for this second phase and what you're doing in the labs for that second phase. And again, it's not necessarily easier, but I think it'll all start to really make a lot more sense during this middle phase of the semester. And then by the third phase, we get out of alignment again. But certainly for these middle 4 to 5 weeks, I think everything should start to click for you. Um, and the fact that you've made it this far is a good thing because not everyone has made it this far. We've had some drops. We've had some people who kind of stopped showing up, and that happens every single semester. But while that exam was not perfect on Wednesday, I saw a lot of really good things as I reviewed your answers, as I saw everyone's attempts. Certainly, I think the proctoring could be tweaked a little bit, and it will be for the next exam we have. But I thought that was relatively minor within the margin for error for proctoring exams, and I think we made the best of a tricky situation at the end there on Wednesday. And I am willing to admit that perhaps the exam was a couple of questions too long. Perhaps. It was a couple of questions too long for everybody. So while that's not a great feeling to have an exam and to not be able to finish the exam and have at least an answer for everything, that was the case for everybody. So in terms of what that means for how you're doing in the class, you're in a very similar situation. Everyone who's here today, certainly the median student in this class, you're doing just fine. I feel pretty good with where we are as a class after having reviewed every single answer for every single exam submission between Wednesday and yesterday. I know a lot of people care a lot about curves and grades, and I care about that too, and I think that's important. My policy has always been that I don't curve an individual assignment or an individual exam. First off, it's very hard to do that in a way that's meaningful. It's kind of arbitrary. I can tell you the statistics, and I'll show you some statistics with regards to the exam, but I think it's much more meaningful to look at the course as a whole, to look at your end of semester performance, the entire of the course, and determine, okay, where do you sit? How did things go? What did the top students in the class, what were they able to accomplish? What were the bottom students in the class able to accomplish? And everything in between. And that's what I plan on doing this semester as well. That doesn't mean I can't share some additional information with regards to this exam, and you can get a good feel from a personal level how you think you're doing relative to your peers. That's not quite the same as a curve. And I'm not going to say specifically if you got a 42 on this exam, that's an A. But if it's a 41, you got an A minus. I don't think the data is that detailed enough to be able to honestly say that. Um, and we can look at the data here. So based on the poll, a lot of people wanted to review the exam. So let's do that today. And we'll start with this is the Excel histogram of how the exam went. I always feel like it looks kind of like someone giving me like the finger, like based on how the histogram looks here. And maybe that's what collectively as a class that you did. So it spans pretty much the entire range. This is points, so it was out of 75 points, not percentages. Although you can do the conversion pretty quickly there. Um, some students did extremely well. Some students, for various reasons, did extremely poorly. But there was a pretty solid, kind of middle ground there. If I had to be, nailed down to a specific curve for this exam in terms of, what was a good outcome on this exam, I would certainly say if you fall into this category over here, I'm not going to call that an A because I'm not curving and giving you a letter grade for this. But I would certainly say if you fell into that category, we had the emojis at the end of the exam. That should be you today. That you fell in that category, you should walk around with a smile today and feel pretty good about what you know about this class to date, at least. If you fall into this next category down here, again, these are not grades. I would certainly say you can still be happy. Of course, I want everyone to be happy, but it's kind of a modest happiness. If you fall into that middle category there, where you're happy, but you can do better. So you're gonna work hard and do better for the remainder of this semester. I don't want anyone to be unhappy. I know life gets in the way. If you fall into this last category here, I would not call that a frown. That is the look of grim determination because you've got some work to do. Honestly, um, you have some work to do if you're in that category. That doesn't mean you're failing the course. That doesn't mean you need to drop the course. We should probably talk. If you fall into that category, um, and let's talk about how things are going. Holistically across all of the things you're doing this semester for the course, and we can have that honest discussion. But there's a ton of points remaining this semester, right? Just all the labs, not just the ones you've already done, the ones that are continuing, the additional exams we have, the homeworks. We still have more than 2/3 of the points this semester remaining, and I want you to recognize that. So even those in the category of grim determination, you can get all the way over to the right by the end of the semester, and I've seen it happen time and time again. Someone's asking about the median, but well, it's a histogram here. The median was roughly a 38 on the exam, so that's roughly half the students on one side of you, half the students on the other side of you. I would say that's not an ideal median. I would have liked it to be significantly higher than that. There was just a lot of variables this time around. I don't know how well of a job I'm good of a job I'm doing, how well I'm trying to help you learn the material. It's hard to figure out the pacing and difficulty of a course as it transitions to this. And then just doing the quiz itself in Canvas maybe adds some additional challenge with regards to being able to show what you know versus just clicking a thing and it may get auto graded correct or completely incorrect. My thought is we're going to have 3 exams this semester, and I'm just going to drop by the end of the semester your lowest of those 3 exams. I don't ever do that, but I'm going to do it this semester. There was enough headaches associated with this very first exam. It went a little different than I would have ideally liked it to. I've learned a lot about how to proctor the exam properly for next time. So even if you're really low and feeling down right now, you can get all the way back. And that's what that policy allows you to do. And if you've done very well in this exam, well, then you're going to be fine. So it doesn't hurt you in any way either. And if you're in the middle, you have the chance to continue in the middle or to improve or to stay where you are. So that's what I'm thinking of doing. I don't see any reason I can't do that, but that's the plan right now. We have these 3 exams at these 3 milestones of the semester. I'll just drop your lowest one. So for those of you who got roughly a 0 on this exam, um, it's not a free lunch, right? Because if you did very poorly, you probably have a lot of catching up conceptually to do, in terms of the material in this class. But you can certainly make it up in terms of your grade. And I do think of those as 2 separate things. Ideally, if you learn the material, that should be reflected in your grade, right? If you really know this stuff, you should be getting an A in this class. I know in practice, life doesn't work out that way, right? We have these rubrics for grading homeworks and labs and even the exams themselves, right? And they look for certain things. And perhaps if you're not a detail oriented person or, you don't like following instructions, right? Um, your grade may not reflect your knowledge of the class. But if I've done my job right, I should be able to set you up such that if you do know the stuff and if you do the work, your grade should reflect ultimately, what you know about this material. So dropping your lowest exam score, I think will help with that. We still need to know MIPS programming. That doesn't go away the entirety of this semester. So it's not a free deal for those who really struggled on this first one, but it gives you a chance at least to get your grade to align with what you think you know with regards to this material. So the regrading policy, and it's a little trickier for this exam than for any other homework or lab, is I would just directly contact me. A DM in Discord or an email is fine. If it's in Discord, you have to provide me enough information that I know who you are and what you're requesting, um, and just let me know. As we go through this exam, there's a couple potential sources of grading error, and I'm willing to look at any request. Be respectful in the request. I'm willing to look at any request. As I mentioned, we had these 2 attempts that some students were able to have to kind of make up for losing a minute or 2 at the end of the proctoring of the exam on Wednesday. your score should not be the sum of those two attempts. What I did is I took whatever points you would have earned on the second attempt, reference that with whatever points on the same questions you would have already earned on the first attempt. So you can't get double the points for the same question you got right, and then added it to the attempt one score. So you shouldn't be looking at the sum of those two attempts. You should just be looking at the attempt one score, and in Canvas it shows up as score was modified by this amount. It should show those fudge points as a separate little thing in the scoring of your exam one. It's very easy to look at those two attempts and say, well, this is a 40 plus a 10. Why don't I have a 50? The answer is that 10 or some subset of those 10 points are already supposed to be included in that 40 you have for the first attempt. That doesn't mean I did it right. That was a lot of exams and a lot of exam attempts and a lot of ambiguity in answers and what I believe to be the right answers, and maybe there were some clever other ways to do things. So I am open to those regrade requests. Let's do it up until a week from today, and let me know. And I'll take a quick look at it. The answer may be no, I'm right and you're wrong. So be it. But it's not the same as a grade grubbing request either, which is not, I have a very sick cat and I really need this A for my scholarships. That's not what I'm asking for right now. I'm asking for on question 7, you gave me 2 points, but clearly I have the right answer, and so give me all 5 points. That's fine, and I'm willing to look at those. Um, okay. Based on pretty much a unanimous survey, there was a request to actually go through the exam questions. I'm just reviewing here to see if I am missing anything, and it looks like we're okay. So, opening up Canvas here, this is supposed to be starting to talk about Lecture 5 material. It is a pretty big break in terms of content, so it's okay that we'll wait for Monday for that. See if I can actually successfully open up the exam here. And that's what you'd be able to see it here as well, having taken it. This is the exam, and I hopefully you're not getting any nightmares from that. Seeing it again, um, I'm not going to belabor this point, but this is true. So I'm joking about a severe beating, but I can catch you. I know this material at a pretty good level, and Canvas also tracks quite a bit of information. It'll say student looked at question 3 and then tabbed out for 30 seconds and then magically had the answer for question 3, even though it should take him 5 minutes to work on it. So don't do it. I will catch you, and then that causes me lots of heartburn, and I don't like to deal with that. So anyway, let's go back, starting with question 1. So yes, those of you who should have entered false for this is fine. We'll move on. But that's question 1. 13 questions. I think if it were 11 of the shorter questions, I think everyone would have felt a lot better about it. So the first question, and it's something I'd be curious to get your input on as well. There was a very consistent, partially correct answer that students gave for this, and my thought was that if you gave this incorrect answer, you'd get kind of turned into a pretzel as you tried to answer the next question. But that didn't turn out to be the case that frequently. So we talked about this a few times over the last couple of weeks, and it's okay. It's 2 separate drop-down boxes because Canvas would not provide partial credit if it was just a single checkbox for this answer. So of the 32 32-bit registers in the register file, which 2 have special ISA functionality, as opposed to functionality that we want the programmer to try to adhere to as he or she writes software? And a lot of people, there you go. Does that look a little bit better for seeing it on the screen? Okay. And you could follow along also, to be honest, on your own copy as well, because there's nothing. I'm not going to be typing up a lot of the answers here. I'll be describing the answers as we go. Which 2 registers have special functionality? And I separated them out in terms of the groupings of registers. 0 is one that most people got because we talked about that so much. And I think the reason you got it is because you've had to actually do that in the lab. So you've gotten to that point in the lab and you've implemented that. For the second one, though, a very common response was the assembler temporary, and we we did talk about the assembler temporary, how it's useful for the assembler to be able to expand more complex instructions to have this temp register set aside for that purpose. But that's entirely software, right? That's entirely the assembler generating software. And so the answer is actually the RA register. And so that's, a good chunk of you got it, a good chunk of you didn't, but that was something that I thought was a relatively fair question. And then I think if you did answer AT for that first question, um, you got kind of confused with regards to trying to answer this next question, which it's really all the same question, which is for those two registers, the zero register and the RA register. It's asking two things here. What is their actual functionality, which can just be a quick sentence, right? Zero stores zero. RA register stores the result of those and link operations for those jump and link, and there's some branch and link instructions. That's part of the question. The second part of the question is how would you architecturally implement this functionality? And I don't want, there's no chance to draw a diagram or anything, but just a brief discussion of for zero, we'd set the reset signal high, or we just wouldn't have a register for zero. There were a lot of good answers and they were all fine. To get full credit for that part, you had to say both. Zero is always zero, and this is how we would do it. And then if you answered AT for the previous question, I was hoping that you would catch it at this point, or if you answered stack pointer or frame pointer, that well, architecturally, how would I do that with regards to the assembler temporary register? How does your architecture know that it's an assembler that's currently running is the piece of software? It would have really no way of knowing that, right? Um, but then for the RA register, we did go through it briefly in class that there'd be some mechanism by which you'd be able to hard code register address 31 for those and link instructions because it doesn't specify the RA register in those and link instructions, but it's kind of implied as part of the ISA that it's register 31 that gets written to. I'm not going to type all that up, but that's what I was looking for. So it was 5 points for this question. A lot of you got like 2.5 on this because you answered the zero part reasonably well, but then you talked about assembler temporary, and I couldn't give you any points for that. Next, we have question 4, which I think, and I even mentioned it briefly on Wednesday, I think was harder than it was supposed to be. Not necessarily like intellectually challenging, it just would take time to do it properly. And I think people would spend like 7, 8, 9 minutes on this question according to Canvas. And that was not the intention. And I didn't think fully about how much time it would take to do this kind of conversion, but it's just asking to do a disassembly of a 32-bit MIPS instruction, and there's no real shortcut to it, to my knowledge. I mean, I guess what one could do is you could open up a calculator and then just do the hex to binary conversion. That would be perfectly fine. For me, it's probably easier on a sheet of paper than to do it via the calculator app because it just there's the regrouping of bits is what would take a long time for that, not the actual conversion from hex to binary and then the associated field. So this is asking to disassemble. I've already lost track. 000A 4A83. And that would be the first step, though, is you have a 32-bit hex value. It's going to be a lot easier to answer the question if you have it in binary. So you can just start to break it out, and the zeros are relatively simple. I don't know if my handwriting is going to be neat enough for this question to be understandable. And I would think it's fair game at this point in the semester that this step of actually converting from hex to binary um, shouldn't itself have been stressful. It's an exam, so everything's stressful, but it's not something that you have to like go look up in a book. How do I convert this? What is A in that we've been pretty hex fluent this semester and will continue to be, and I would expect you to be able to do that in about 5 seconds or whatever it was that it took for us to do it. Endianness doesn't really matter for this, or if it does, to the extent we've been very consistent with how we've been mapping things out. If somebody answered that question I don't know how you would have answered it in backwards order. It's not an endianness issue at all, right? That's how you transfer bytes within a word. This is a 32-bit value. That's just the binary string here. If you somehow manage to answer the question with an exact like bit string, you can contact me about that. A48. I must be. Thank you. A4A. Well, doesn't that stink? Okay. A4A83. See, how can you possibly make this mistake during the exam? A4A83. Thank you. And then thank you. Once you have that 32-bit bit string, now it's just a matter of remembering, well, at the very least, I don't know very much about this instruction yet, but I know where I can look to figure out more about the instruction is the opcode. And I certainly made it intentionally the case that your opcode is 0. So that tells us a lot about how to answer this question. For example, it does tell us the remainder of the fields, but it also lets us know, and the question says, if the instruction does not have a field enter -1, there wouldn't be an immediate field, 16-bit immediate field for this instruction. You could put -1 for that because it's not an I-type instruction, it's an R-type instruction. And with our R-type instructions, we can then just figure out the remainder of the fields. We would have our func field, we would have our 5-bit shift amount field. You have to be a little bit neater than I'm being if you want this to be accurate. And then you're going to have your register fields. And then so those would be your register fields at 10 and I can't even read it myself. 10 and 9 for those two registers that we have there, and then that would be your shift amount would also be 10 for this instruction as well. The only thing that I think if I could do the exam again, it was equally annoying for everybody, is that that function code doesn't show up in the green card. It should. It's not there. So after I kept saying on multiple occasions, the green card's a good resource to have handy, and it is. But if you look at the function codes that are listed here, shift right arithmetic, for whatever reason, I guess they ran out of space, does not appear to be here on this green card. And if it's here, it is here. It's just hidden on this side. So you would have had to have been very fluent to know that that 3 corresponds to shift right arithmetic for this. There are other resources, when you yourself are building your control logic. I've always mentioned Mars is a good resource, but during an exam, it's not a good resource. The other resources that are always good to be able to determine what your various opcodes and function codes are. If you look at not just the green card, there's also I don't know what the right word for it would be. The opcode map. I'd have to bring this over so you can see it. This is straight from the textbook. This is a figure from the textbook. This isn't something I created. And that's just the actual layout of all the individual opcodes. So here for our opcodes, if it's 0, you then look at the function codes, and then here you can get a pretty clear breakdown of what the various function codes correspond to instruction by instruction. I'm not losing sleep over that being a slightly annoying question. For that part specifically, that was 1 point, and so life moves on. This is another question that I would like you to have known. I guess for all these questions, I would like you to have known. That's why I put it on the and let me know if I marked something wrong with regards to that. If you put NA, it would have auto graded wrong, but I can give you points back. But I didn't see too many of that. It does say -1 on the question. So this question is asked about jumps, and it's posing the hypothetical. Let's say we don't have a jump instruction anymore, a regular jump instruction of the J type, and instead we're replacing it with a branch in which it's always going to be taken, which branch equals 0, 0, because 0 is guaranteed um, to equal 0, and so that equality will always be true, and so we will always be taking that branch. What would be the effect of replacing that jump instruction with an always taken branch of any type? But that's the example given there. Some people answered, and I did give some partial credit depending on how how fluent your answer was with regards to this. Tried to talk a little bit about performance in terms of, well, the branch is doing more stuff, and so that branch is going to be slower than the equivalent jump. The truth of that is pretty subtle and not strictly true in and of itself. So I certainly couldn't give full credit for it, and depending on how you describe that, I did give a varying amount of partial credit from 1 to maybe 2 points for that particular question. That's not really what the question's getting at. We actually haven't really discussed and don't truly know, beyond our simple analysis we've done of critical path already, why a branch could or could not be a different performance profile than a jump instruction. And the truth is, it really isn't for the most part. What we have been able to discuss, though, is the actual encoding of those instructions. So, with that jump being the J type and that branch being the I type, that is the crux of this question, which is because it's a J type, if we get rid of all those jumps and replace it with the equivalent I type branch instructions, we're not going to be able to jump as far. And that's all the question's asking. So, if you had code that was dependent on being able to jump a reasonably long distance, more than 2 to the 15 instructions away in either direction, right? Jump allows you to do that. That branch would not allow you to do that. You wouldn't be able to encode that distance in the branch instruction itself. You'd have to have some other solution for jumping further away. That's what I was getting at with that question. A lot of you answered it in really specific detail about the exact ranges, but just the difference in distance of jumping is what I was looking for that particular question. So this is a question that's I attempted to auto grade, but there was a lot of close answers that I wanted to give partial credit for. So you will see some people got 2.5 or 3 points on this question. So it's asking about how many unique types of instructions can the MIPS ISA support. So a little bit is just remembering a little bit of our base to arithmetic or our binary to encoding to total possibilities. I even tried to explain a little bit because I didn't want you to answer 3 for this question, and I didn't give 3 any points for someone who just answered 3, because I could see you thinking and saying, "Oh, R type, I type, and J type. That's 3 unique types of instructions." So I specifically said, load word, add, and XOR are themselves 3 different unique instructions. So the answer is not 3 for this question. It was a little hard to grade because I said you could leave it in the form of an expression. So I typed in every single possibility I thought of as what would be a valid expression to get to the quote unquote correct answer. And I still found several. I had to go back and check. And that's okay as well. But this has to do with the binary encoding space for our MIPS ISA, at least the version learned to date in class. And by the way, those of you who answered 2 to the 32, which that's a bit of semantics. I gave full credit for that. If you answered 2 to the 32, the argument being that every possible encoding of a 32-bit instruction is a unique instruction. It's not what I was getting at, but I think you have a semantic point, and I didn't want to fight anyone. So that you got full credit if you did answer that. That's not what I was going for. What I was going for had more to do with, again, that opcode and function code expansion. We know all of our instructions have that 6-bit opcode. And I think that's an important thing to know by this point in the semester, that if there's a 6-bit opcode, that's going to allow us to encode 2 to the 6 unique opcodes, right? And if you put 2 to the 5 or something, I may have given some small partial credit. But at this point in the semester, and if you said like -2 to 5 to 2 to the 5, that's not quite right here, right? We have 6 bits. That's 2 to the 6 unique things, right? From 0 to 63 in decimals, what we can encode with that 6-bit binary value representing the opcode. That would only be partial credit because we do then know also that for when the opcode equals 0, we also have that 6-bit function code, which effectively, and with the caveat that if we look at the entirety of MIPS, can't seem to open that up. If we look at the entirety of MIPS, there is a lot more going on in terms of it's not quite as clean as the textbook makes it sound. There's additional other fields. But for the textbook stuff that we've been learning so far, it's the opcode and it's the function code that we're using to encode our unique instructions here. If that is 2 to the 6 for our opcode field and 2 to the 6 for our function code field, the answer is not 2 to the 12. You're not multiplying those spaces together. It's only for when the opcode equals 0, do we have a function code for those R-type instructions? So it's actually 2 to the 6 plus 2 to the 6. And then if we really want to be precise, although I gave full credit either way, you don't want to be double counting that opcode equals 0 case. So it'd be 2 to the 6 plus 2 to the 6 minus 1 instructions that would be unique with that encoding. Because we're already counting the opcode for opcode equals 0. It's not a separate instruction. It's only a set of those function code instructions. So the answer is 127. If you put 128, I gave full credit. If you gave 2 to the 32, I gave full credit for it as well. And for some, I was able to give partial credit. If you wrote 2 to the 6, I gave some partial credit for that one. So again, if this was a 2-hour quiz, I think things are going well and we're making good progress on it. The issue is that maybe at this point, depending on how much how much time you took on question 4, you may now have 10 minutes remaining, and I could see why that would be a very stressful situation. Um, Question 7, I said there was no trick questions on this exam. I don't think this is a trick question. I think this was a tricky question. That may be a slightly subtle difference there. So the question is asking about pseudo instructions, and I think I dropped enough hints that pseudo instruction questions are kind of nice to ask on quizzes and exams because they're very self-contained little questions. I don't need to have you translate a huge block of C code. It can be a very simple thing that you're translating. And so the question is asking for that add immediate instruction. Is it a native instruction or is it actually a pseudo instruction that the assembler would have to handle to do some translation at assembly time? And it's not, again, I don't think it's a trick question, but the reason it's tricky is I gave, I think, some plausible answers in the drop down that I think you could have clicked and moved on and thought you got it, but you may have missed it. So, for example, a lot of people said it's a native instruction because add-I has its own opcode. That is both true and not correct for this question, right? So add-I does have its own opcode. Add-I is a native instruction, but for this example here, it's not going to be a native instruction. The assembler is going to have to translate it. So, and some people put the hex value, but hex is just one way we encode the constants that we have here. But the reason this is not going to fit into a native instruction is because we actually have more than 16 bits encoded for that immediate, right? So add I is that immediate, or that I type instruction. As part of the native instructions of our I types, we encode up to a 16-bit immediate for it. And in this case, as the programmer, we try to provide a 24-bit immediate for this. The assembler is going to be able to handle that for us. And someone had asked in a different context, how many pseudo instructions are there? That's actually a little tricky to answer because that's really up to the assembler. The assembler can make all sorts of things pseudo instructions. As long as the assembler can then translate it down to native instructions, there's not really a strict limit like there is for the ISA supported set of instructions. But in this case, the assembler would be able to take it and say, well, you wanted to add this 24-bit constant. Let me use other instructions to load that into a register and then replace this add I with just an add instruction instead. And that's the reason that's a pseudo instruction, because the immediate value is larger than that 16 bits that you'd be able to directly encode in a native instruction. This was an interesting one. Again, it's kind of a pseudo instruction question. Some partial credit, and I will be honest. And if you want more precise feedback on your exams and for your exam, I can certainly provide it. When this was a paper exam and I had just my stack of red pens, I would write things down for here's why you lost 2 points, here's why you lost 3 points. I ran out of some energy to do that on this exam. And so for some of you, I did provide a comment as to why points were taken off or why you got some points and not all the points for it. For this one, I'm glad we're taking the time to discuss it because it may not be that clear why you may have lost points on this one. It asks two things that can be answered very quickly, but two separate things is what it's asking for. Give the instruction a name and describe what it does. And I think a lot of people took that request and just tried to say matter of factly, this first instruction adds 0 to T1 and stores the result in T0. The next instruction checks if 0 is less than T1 and stores the result in AT. And you just kind of walk through, here's my understanding of what these four instructions do in isolation. But that's not really what the question's getting at. It's not trace four lines of code and demonstrate you know what those four lines of code just do conceptually. It's collectively, what does this do? And I did give you some partial credit if you did just kind of walk through and said, well, it branches. This is a branch instruction because it branches away. It does branch away, but that's not the point of this instruction. The gotcha, or the part that I think in the time constraints and pressure constraints of an exam it was easy to miss, was really this final subtract instruction. Right? This is a subtract instruction where the order of the operations for a subtract instruction matters, right? For an add, it doesn't matter which one's first and which one's second. For a subtract, it does. We're taking 0 minus T1, and where T1 is our input register, and we're storing the result as T0, where T0 is our output register. So 0 minus T1 is setting T0 equal to negative T1. And some people got to that point and said, well, then this is a negative instruction. It always inverts T1 and stores the result as T0. That's not quite correct. You got a lot of points if you answered that because that means you were able to get through it. But it starts off by setting T0 equal to T1, and it only inverts it if this branch is not taken. And this branch is taken when that value is positive. So it looks to see if the input is negative. If the input is negative, it doesn't take that branch, and it then calculates the inverse of it. Otherwise, it just continues on. So it's not quite a make negative. Another word for it would be make positive instead, or absolute value. And frankly, if someone just wrote absolute value, you got full credit for that, because to be able to answer that, you had to trace through all those instructions and connect it all together. You got partial credit if you just kind of walked me through what the instructions were doing individually. But if you got the final, putting it all together wrong, you lost at least a couple points on that question. I didn't put comments for most of you for that one. I wanted to get the exam graded. This one was a little tricky too. Wasn't supposed to be. And there's maybe the tricky part is there's a lot of potential ways to do it, but it did require you understand that binary notation again. So and this was a pain to do in Canvas, even made a little diagram here using a table showing which byte I want you to zero out of the four. So this is called 0-second byte, which takes a 32-bit input value and returns the result for which you have all the original input values and you just zeroed out that second byte. Yes, that's an arbitrary instruction. It's kind of silly in isolation. It's again though why I like these little pseudo instruction questions. We could have done a C code version of this. It would have been harder to read, harder to understand what I was asking for. Here it's just, hey, just zero the second byte. Here's visually what it looks like. A lot of you did recognize that the easiest way to do that would be via some AND operator. Can I AND out those 8 bits corresponding to that second least significant byte in my 4-byte word that I have here? But a good chunk of you, I would say, struggled with remembering what that means from sort of a bit manipulation perspective. And a lot of the constants were wrong. A lot of you were actually zeroing out the second bit, or a lot of you were zeroing out the second nibble. And part of the challenge is, again, for our immediate types, we only have 16 bits to work with. So you can't actually easily do it in one instruction in MIPS. It does require more than one instruction. You have to be able to basically build a 32-bit bit mask for this, which is going to take 2 instructions. You could use pseudo instructions as well, and then do an AND of that bit mask to get the result back out. So you have to build its FF00FFFF as your bit mask, and then AND it with the input to get the output. There's some other ways we could do it, similar to the example we did cover on Monday, where you're shifting things around to get rid of it, and then shift it back, and then OR it with the original. That also worked. But even there, a lot of you were shifting it 2 bits and then shifting it 4 bits, and that's not right. This would be an 8-bit shift to get this to be the least significant bit, a 24-bit shift to get it all the way zeroed out to the left. So you have to be able to make that connection between that second byte and what that means in terms of bits. But then within that, there was a lot of creativity, a lot of different ways people were able to answer that question and get a lot of points for it. This one probably was easier if it wasn't in Canvas. I wanted to make as many sort of auto-graded questions as I could. Um, easier said than done, basically, and that's what I attempted for this one. That implement the equivalent of a pop operation, and we did talk about this pretty explicitly in class. That MIPS at least doesn't have a pop instruction, but it's a very common thing you want to be able to do. I want to be able to pop the most recent value off the stack, the top of the stack off, and store it in a register. So when we say pop v0, and this would be part of the answer for this. Um, you would actually have to store the result in V0 for this to be correct. The reason I think it's kind of annoying is just because that syntax, it just looks a little funny. Now, it does give a lot away, right? That clearly this is going to be a load instruction here to start with. We got to grab the value off the stack. That parenthesis is kind of the big giveaway because that's the only instruction we're using that has parentheses as part of the assembly for it. And then we have to do something else. And as we've talked about, our stack manipulation in MIPS is always either a load or a store, plus some arithmetic to kind of keep track of the stack pointer. And there wasn't really any opportunity for partial credit. You could get the individual parts right or wrong, so that's why you would get partial credit. There was no opportunity for me really to give back any points if Canvas took them off for this because it was just drop down. So it's a 32-bit value that we're loading. So load word would be the correct thing. Um, this is a lot of people put T0 for here. A lot of people did, and you lost a point for that. I, I'm not sure why, other than you were just thinking we want to pop into a temporary. Uh, well, don't lose sleep over that if that's what you were thinking. That's fine. It was saying, we want to pop into the V0 register that would store it in the V0 register. So that's what we would have there. Then we would have our offset, and then that's all going to be relative to stack pointer. And likewise, then there's always going to be that add immediate from the stack pointer into the stack pointer. And I was not lazy is not the right word, but I was getting tired of providing so many different possibilities. And so for this one, I said it's stack pointer. Don't select this option. And some of you selected that option. I don't know. You lost a point for it. I don't know. That's fine. Just a couple of you. Um, there were a couple different possibilities for how you could have answered it, but if we look at our the way we have been doing it, we've been loading relative to the top of the stack, so that value at 0, and then we've been popping it off, so the stack is growing. So the stack is then shrinking. Yeah, the stack is then shrinking now because we're popping things, right? So it grows backwards into memory. So now that we're shrinking, our stack pointer actually has to go up, not down. Our stack is shrinking. That means our stack pointer goes up, and that would be the correct answer for that question. And really, no partial credit for that. If you did exactly that, you got them all right. For anyone you got wrong, you lost a weird fractional amount of points based on 5/8, basically. It's not that weird of a fraction, but you know what I mean. And now when we get to 11, 12, and 13, I'm not going to assume too much about what you as a class collectively knew or didn't know coming into this exam, just because I know that time was really maybe more of the pressure than anything else. So I think for these three questions, if you had an hour, if it was a homework assignment, you'd be just fine on it. It was an exam and the time was a real crunch. I got that. But this is asking for another pseudo instruction, but it's kind of turning the questions on its head, and it's saying, well, the begezel instruction, or branch greater than equal to 0 in link, it could have been a pseudo instruction. It just actually happens to be a native instruction in MIPS, and we won't be supporting it when we do our projects. We could, by the way. There's nothing, nothing fundamentally preventing us from being able to support these. Just a matter of how many hours we want to spend on our projects in this class. But there are some really weird instructions in terms of how they break the nice clean mold of R type, I type, and J type of our decoding. And those branch comparisons to zeros all fall into that category there. So your begezel instruction is one of those. Branch less than 0, or actually, they're actually all native instructions and not pseudo instructions. But the question is still pretty valid from the perspective, okay, if it didn't exist, how would we implement it anyway? So again, the reason I like the pseudo instruction questions is I'm asking for a very precise assembly level functionality, and how would you implement it with other instructions? There was a lot of possibilities here because not only is there a branch greater than or equal to 0 in length, there's actually a branch less than or equal to 0 in length. And if you have that, then it's a very easy question to answer. Unfortunately, you just reverse, the operands and you're done. The idea is how do you do it with regular branches and jumps is all it's asking. How do I do a branch greater than or equal to 0? The correct solutions had some form of two branches in it or some manipulation of the value itself so that with a single branch you could determine if it was greater than or equal to 0. And there was a lot of possibilities. You did lose, I don't recall how many points, not that many, but if you didn't have the and link functionality. So that is part of it, right? So the answer is not just two branches. It's got to be a branch to a jump and link, or a branch away from what falls down into a jump and link operation. Because it only works if you're actually then doing the and link part of it, the storing of the RA register. Um, and it didn't require, depending on how you interpreted this question, people did in fact get full credit for just describing in English, what they would do, and not actually writing out perfect assembly code. But you were able to get full credit doing it either way for this question. I think if there wasn't a crunch time, that would have been okay. Certainly for this one as well. Um, I think it's easier on a paper exam to kind of like scan through it and say, okay, I'm low on time. Let me get more points. Let me sort by difficulty, perhaps, or by which ones I can answer very quickly. If this had been the first question on the exam, I think everyone would have gotten it correctly. Or let me at least say, when you're benchmarking yourself this semester and how you're doing, and maybe you were below the median, maybe you were above the median on the exam, maybe labs are going well, maybe you're struggling. For the in-class content for that first third of the semester, I expect you to be able to do this without like pain, without struggle, um, because that is something through the examples we've done, through what we've learned. This is not a very complicated example. I'll just say that you have a sum variable and you have an I variable. I tell you, so your assumptions don't really have to be really stated very much. Where what registers they're stored in, N is stored in S2. So basically, is can you make a for loop in MIPS is what this question is asking, and it can be done in very few instructions. You need to add +1 to I, so that's an add immediate. You need to add to sum, so via a regular add instruction, and you need some set less than slash branch for I and N. So you can really do it with four instructions in your loop, and that's what I was looking for. And in this one, you had to actually provide the assembly because I did say hand compile this loop into MIPS assembly language. And and this one I would say was also a function of both time you had remaining as well as how you prepared for the exam. This semester, we did not spend a ton of time going through an example that looked like this in our time together in class. And I realized we were maybe either falling behind or I was just going a little bit slower on other topics. I did provide and I tried to share that as many times as possible with people, basically this exact example and what that would mean in terms of MIPS assembly for just a fairly complicated array accessing example. And the one way to think about it is, and I didn't ask you to do it from scratch, which would have been a much longer, harder question, is you can think of working from inside out with regards to this. That this D of really complicated expression could just be thought of D of temp. And then the rest of your work is how do I calculate that temp? And likewise, you can just figure out the array arithmetic for those and add them all together to get to that temp value to do those loads at the very end of the day. Remembering that we have different data types of different size. I think in the interest of time, we're not going to be able to get to this one today. Um, but for example, I tried to provide, although there was a couple typos we found during the exam, but I think there was enough there for you to be able to answer it. For example, we're going to do that 4 times I calculation um, because we have to do that a lot, right? To calculate our byte offsets into memory. So the answer for this one is literally just 2, right? We're doing a shift left logical of 2. Then we want to add, this should say T1, but T1's listed here. If the address of A is as 0, we want to add that I offset into A into this value. That would be add or add U. I'll give you credit. I gave you credit for either of those, and so forth for all of these. it was really, it could have been a harder question if it was just, write all the raw assembly. Would have been a lot harder and longer for me to grade. I was looking for those exact patterns to kind of fill in the blanks for those assembly instructions there. And then, and so I would say, in terms of the big picture concepts of this class, is being able to do annoying looking array arithmetic and MIPS really all that important? Maybe not. But to be able to do that, you should be pretty fluent in regular array arithmetic and MIPS and that design pattern of shift left logical add load, shift left logical add store. You should know that at this point in the semester. That's an important thing to be pretty comfortable with at this point in the semester. And then finally, last but not least, Joseph Jr. is having a bad day. It wasn't just Joseph Jr. A lot of us had a bad day on Wednesday. Um, this was a question that I think was probably a 15-minute question, and you had maybe a minute to work on it. So a lot of people struggled with this one. The truth is, there is 6 bugs I wanted you to find in here, and so you would have actually gotten a lot of credit. And I don't think that's quite right. If you just said no error on every single line, you would have gotten like 4 or 5 points out of the total points for this 10-point question. Um, we'll leave things here for today. Now, if you have time to look back at this question, it's not a hard question. There's certain things that are clearly being done in either the wrong order or are just logically incorrect with it. But I do know, looking at it now in the benefit of the whole timing for the entire exam, this is a very hard question if you have a minute or 2 minutes to work on it. And so um, that's why our average worked out to be the way it was for this exam. So that's, and it is what it is in terms of that, and I'm cognizant of that fact. So big picture here is, I think you should be encouraged. You're here today, you've made it a third of the way through the semester. I very much think you should be encouraged with where you are in the semester. I can't speak to your lab progress, how far behind you may feel you are in labs, but you've gotten to this part. This middle third of the semester, it's not going to be easy. It's never easy. This is a tough course, but it's gonna be aligned a lot better, I think. And I think you'll find the time you're spent on labs and the time we spend together in class and the time you spend on homework, it's all going to feel like it's part of some cohesive unit versus 3 different classes kind of smushed together. That first third of the semester felt like occasionally, I think. And that should make life a lot less stressful. Likewise, you're going to be starting working next week with teams, depending on the quality of your team and how good of a teammate you have. That may be less stress. That may make life a lot easier for you. At least it's someone who you can commiserate with and not feel that you're all alone working on all this material you have. The semester's, I think, going to get a lot better for a lot of you. And I ask you to persevere and stick it out because I think it's going to be okay by the end. Let's leave things here for today. And on Friday, we definitely have to start up that material on looking at performance. It's kind of a one-off material, but we should be able to get through it pretty quickly. And I look forward to us doing that on Monday. Otherwise, enjoy your weekend and look forward to seeing everyone then.